Okay, Dr. Jenkins here again. This short little clip is going to be reviewing the blood volumes as they move through the heart. Particularly, what I'm interested in trying to explain quickly is the end diastolic volume. Maybe you've seen EDV, end diastolic volume, and the end systolic volume. Now, when we are talking about end diastolic volume and end systolic volume, it is always about the ventricles. So whenever you hear end diastolic volume, that means the volume of blood after ventricular diastole. Even though it just says end diastolic, it doesn't say end ventricular diastolic, that's what they mean. The volume of blood in the ventricles after ventricular diastole versus end systolic volume is the volume of blood in the ventricles after ventricular systole. So just automatically add ventricular. So we're referring only to the ventricles. Check it out. At the start of the cardiac cycle, even before we begin with the atrial walls contracting, as we established, there's some volume in the ventricles left over from the previous cardiac cycle. So even when we start a new cardiac cycle, do you see there's some blood in the ventricles? Yes, it's left over from the previous one. It's around 60 mils at rest. So even before we start a new cardiac cycle, there's about 60 mils of fluid in the ventricles. You don't need to know that number, but that's what it is, just to put a number to it. Now, we also add a little bit more to the ventricles that is added passively during atrial diastole. Okay, so an additional 30 mils moves from the atria into the ventricles, which means that even before we begin atrial systole, which is going to happen here, even before we begin atrial systole, there's a total volume of about 90 mils. It was a 60 mils from the previous cycle plus an additional 30. 60 plus 30 is 90. Then the atrial walls contract and push the remaining blood from the atria into the ventricles. That's where we get an additional 40. So we had 60 plus 30 plus 40 means that at the end of atrial systole, at rest, there's about 100 mils of fluid in the ventricles. That is what's considered the end diastolic volume. Because at the end of ventricular diastole, by the way, during atrial systole, what are the ventricles doing? When one set of chambers is contracting, the other is relaxing. Excuse me, I had to sneeze there. So when the atrial walls are contracting, systole, the ventricular walls are relaxed. Excuse me again. So the end diastolic volume, the volume of blood in the ventricles after ventricular diastole, which is the same as atrial systole, is about 130 mils. Then, what are the ventricles going to do? They're going to contract. So we had 130 mils, and we're going to pump out at rest about 70. So we started with 130 mils in the ventricles. At rest, we tend to pump out about 70 mils per stroke. That's the stroke volume. So we pump out 70 mils, 130 that we started with, minus the 70 mils we pump out, leaves 60. So the end systolic volume is 60 mils. It's the volume in the ventricles after ventricular systole. And if I wanted to, couldn't I calculate the ejection fraction? If I really wanted to, couldn't I calculate the ejection fraction? because in this example of a heart at rest, under resting conditions, we pumped out 70 mils out of a possible 130. So I can do the math, right? 70 divided by 130, 54%. 55% usually. It's about 55%. Cool. Two more things to point out really quickly, and then we're all done. Notice that we end with the same thing that we started with. So at the beginning of the cardiac cycle, we had 60 mils left over from the previous one. We go through a whole new cardiac cycle. What are we left with? 60 mils, which is going to be transferred back to the next one. How might this change with exercise? Well, if we start to bring in more blood to the heart, if we started with, instead of 60, if we started with 80, we'd be left with 80. So those two numbers need to be the same, because what we're going to find out is that the heart pumps out whatever volume comes into it. Volume in equals volume out. And the last thing I want to mention, and then we're all done, is what about the atria? Well, it's generally established that pretty much all of the blood from the atria does move down to the ventricles. So even though after the ventricles contract, we know that there's still an end systolic volume, there's still some left over, we don't pump out of the ventricles every drop, it's pretty established that almost all of the blood does move from the atria to the ventricles. So there's not necessarily a volume of blood chilling out in the atria. All right, folks, another good one.